Sir, from your extraordinary outlook, I can tell you must be a pioneer in the agricultural industry. Yes, I am. How do you know? Spirit. Our company has newly developed a fertilizer, namely K. Our group of medical scientists have developed a medical formula with a medical experimental setup. And the results are, of course, medical, impossible. Fertilizer A is a fact. No, no, no. Impossible is nothing. Let me show you our results medically.
We want to test whether the performance of fertilizer K is better than that of fertilizer A. It will be the case if we reject the null hypothesis. The parameters we will measure are, first, the average total yield of all watermelons in a plot, and second, the average weight of one single watermelon. These two parameters differ as there is no guarantee all watermelon seedlings can survive and grow. These parameters reflect the potential total profit and per watermelon profit for the farmer. Operationally, we have two null hypotheses. The first one is the average total weight of all watermelons in a plot treated with fertilizer K will be smaller than or equal to that with fertilizer A. The second one is the average weight of one single watermelon treated with K will be smaller than or equal to that with A. Watermelons need space to grow. Previous studies suggest it's sensible to have a 2-meter separation between two watermelons. So we have decided 256 study areas in the field, and each study area is further divided into 4 plots. Each plot is 10 times 10 meters square in size and will grow 16 watermelons. To avoid mixing of fertilizers, we leave a 5-meter gap between plots. In each study area, 2 plots will receive the fertilizer K and the other 2 plots will receive the fertilizer A. Each plot will actually have different conditions for watermelons to grow due to the differences in water availability, gradient, and so on. Therefore, random allocation is performed to avoid the results from being heavily influenced by factors other than fertilizers. Following the common practice of the industry, we buy the same batch of watermelon seedlings and plant them randomly in the field. After acclimatization for a week, we start to add fertilizers in each plot. This is done once a week for 2 months, and throughout the process, we need to give the same amount of insecticide, herbicide, and irrigation to all the plots. At the end of the growing season, sample watermelons are harvested at the same time for fair comparisons. When doing the measurements, we buy standard masses to test the accuracy of the electronic balance. Try putting the standard mass on the balance for a few times can ensure its display number does not fluctuate a lot. This should be repeated after every 50 measurements to ensure accuracy throughout data collection. And to avoid human errors in recording, data entry is done by 2 people separately, and later we can use computer programs to compare the 2 sets of data. If there are different numbers in the same data blank, that set of data should be neglected. We will randomly sample 30 study areas. For the total yield, we measure the total weight of all watermelons in every sample plot treated with fertilizer K and take the mean. Then do the same for fertilizer A. For the weight of a single watermelon, 4 watermelons from each plot will be chosen randomly for weighing, and all sample areas will give the mean of average weight of a single watermelon. We can visualize the results from histograms, and we then need to check whether the datasets distribute normally or have equal variance. If they don't, we need to either transform the data or perform the non-parametric test. If the data passes the normality and equivariance check, we can move on to one-tailed 2-sample independent t-test. For each hypothesis, if the calculated t-value is greater than the critical value, we can reject the null hypothesis. Otherwise, we should check the power of the test before accepting the null hypothesis. If we reject the null hypothesis, then we can tell the new fertilizer K can bring a higher total yield per plot and a greater average weight of each watermelon. However, the performance of the fertilizers may be represented by other factors, such as whether the watermelons look or taste better or can be harvested earlier. We can also try varying the method of fertilizer application to see how to get the most out of the fertilizer. If we can have one more year for the experiment, we could have performed a pilot test. There are also confounding factors which cannot be controlled throughout the experiment. They include natural variations, pre-existing fertilizers in soil, and the different conditions of each plot.